There's sunlight coming through a window somewhere near you right now. And it's doing something to your cells that has nothing at all to do with vitamin D. I want to walk you through one of the strangest facts in cell biology, and then I want to tell you honestly where it stops being solid, because that second part matters more than the first. Let's start with the strange fact. You have an enzyme in your mitochondria that absorbs light. Not metaphorically. Not in the sense of light triggering some hormone somewhere. This particular protein physically catches photons, because of what it's made of. It's called cytochrome C oxidase, and it's one of the most important proteins in your body. It sits at the very end of your electron transport chain. If you've watched my other videos, you'll know the chain is how your mitochondria produce ATP, the energy currency your cells actually spend. Electrons get passed down a line of components, and each handoff does work. Cytochrome C oxidase is the last one in that line. Complex 4. It takes electrons from the carrier before it and hands them to oxygen, which is why you breathe. That's the reaction. Oxygen plus electrons plus protons becomes water, and the chain can keep running. Now, here's why it absorbs light. To do that chemistry, the enzyme is built around metal centers. 2 copper centers and 2 heme centers, which contain iron. And metal centers in proteins interact with light. They absorb specific wavelengths depending on their structure and their oxidation state. The copper centers in cytochrome C oxidase absorb broadly across the infrared range, roughly 700 to 1000 nanometers. And the whole enzyme absorbs across the red and near infrared band, roughly 600 to 940. So you have a light-absorbing protein sitting at the terminal step of your energy production. That's just true. It's structural chemistry. The next question is the interesting one. Does absorbing that light change what the enzyme does? The leading proposal goes like this. Nitric oxide, a signaling molecule your body produces constantly, can bind to cytochrome C oxidase at the same site oxygen uses. When it does, it competes with oxygen and slows the enzyme down. That's a real regulatory mechanism, not a malfunction. The photobiomodulation hypothesis says that when red or near-infrared photons get absorbed by those metal centers, one of the consequences is that the nitric oxide gets displaced. The site opens back up for oxygen. The enzyme picks up speed. Oxygen consumption increases, membrane potential rises, and ATP output goes up with it. That's the mechanism. Now let's talk about evidence, because a mechanism that sounds good is not the same as a result. The best kind of evidence here is measuring the thing directly in a living person. And that's been done. Researchers used near-infrared spectroscopy, which is a way of measuring what's happening in tissue by shining light through it and analyzing what comes back. They applied a 1064 nanometer laser to the forearms of 11 healthy volunteers, with a placebo condition for comparison. And they tracked cytochrome C oxidase concentration at the treated site. It went up significantly. And it climbed as the laser dose accumulated over time. Oxygenated hemoglobin rose alongside it. So in a controlled setting, applying that light to human tissue measurably changed the amount of this enzyme. That's a real result. Alright. Now the part you're waiting for. If light does this, and you'd like some, where do you get it? The honest answer is that the largest source of red and near-infrared light in your life is not for sale. It's the sun. Close to half the energy arriving from the sun is infrared. You don't perceive it, because your eyes aren't built to. But it's there in enormous quantity, every day, for free. And there is no device you can buy that delivers it at that scale. So the free lever for today is about as simple as it gets. Go outside. Morning is a good time for other reasons too. 20 minutes. Leave the phone in your pocket. That's it. That's the action. But I promised you honesty about where this stops being solid, so here it is, and I want you to actually hear this part. Nobody has run the study that proves standing outside reproduces what those lasers did. The lab work uses specific wavelengths, specific power densities, specific durations, applied directly to a target. Sunlight is broadband, variable, and arrives at whatever angle it arrives at. It's entirely reasonable to think you're getting some version of the effect. It has not been demonstrated the way the laser studies demonstrated theirs. If I told you otherwise, I'd be doing the thing I built this channel to avoid. Second honest point. In photobiomodulation, more is not better. The dose response is biphasic, meaning there's a window where you get an effect, and going past it can reduce the effect or reverse it. This is well documented in that literature. So the instinct to think if 20 minutes is good, 3 hours must be better, is wrong. And beyond the mitochondrial question entirely, burning your skin does you no good whatsoever. Don't turn a free lever into a sunburn. Third, what about the panels? Red light panels are everywhere now, and I want to be fair. The mechanism they're built on is the one I just described. It's real. It's not invented marketing. And the device studies that use controlled wavelengths and doses are where most of the good evidence actually comes from. What I haven't seen is anyone demonstrating that a consumer panel outperforms simply getting outside. That comparison, as far as I can tell, hasn't been run. So if you own one, fine. If you're about to buy one, I'd spend the 20 minutes outside first and see whether you notice anything, because that experiment is free. Now let me tell you where my own recommendation sits, and it's a narrow one today. Cytochrome C oxidase is the last stop in the electron transport chain. It's the destination. CoQ10 is one of the carriers earlier in that same chain, shuttling electrons along toward that final step. Same assembly line, different station. And levels of it do tend to decline as we age. I want to be precise here, because it would be easy to blur this. I'm not telling you that taking CoQ10 enhances the light effect. Nobody's shown that, and I'm not going to imply it. What I'm telling you is that we spent this whole video looking at one end of a chain, and CoQ10 works at another point on the same chain. That's the honest relationship. Nothing more. So the order is this. Go outside. That's free, it's pleasant, and the mechanism behind it is real even if the everyday dose hasn't been formally tested. And if you want to support the machinery itself, the link in the description below is an affiliate link to Mitochondrial, which is PQQ and CoQ10, and it comes with a 90-day money-back guarantee. If you'd rather get your science with the limitations left in, subscribe. That's the whole idea here. This video is educational only and it's not medical advice. Talk to your doctor before starting anything new, and be sensible about sun exposure, especially if you have skin conditions or take medication that affects light sensitivity.